In this video, we will explore the definition, necessity, and examples of tensors to understand why tensors are used in artificial intelligence. To briefly explain the basic principles of how artificial intelligence works, AI focuses on training with data X and Y to find patterns, and then using those patterns to predict what Y will be when a new X is input. For example, if you input 7 as X and 10 as the corresponding Y, the AI might discover a model where Y equals X plus 3. If this model is connected to the internet or an app, and a user inputs a new number like 20, the AI will predict the result to be 23. Let's explain this with a more specific example of predicting house prices. If we predict house prices based solely on the size of the house, we can represent this with a simple linear function. However, factors other than size also affect house prices, such as how old the house is. In that case, you can represent the size of the house as x1 and the age of the house as x2 in the prediction equation. If you then add the distance to the nearest subway station as another factor, the equation would include 3 features. As the number of factors increases, the equation becomes more complex. In other words, to accurately predict house prices, you need to consider multiple factors rather than just one. However, doing so makes the equation more complicated and requires more calculations. Let's assume that there are 3 factors: size, age of the house, and distance to the nearest subway station, and this represents the equation for predicting house prices. In this case, if you input the values from the existing data shown in this table into the equation, it could be represented as something like omega 1 times 15 plus omega 2 times 5 plus omega 3 times 10 plus a bias term, b is equal to 1000. When you express this using matrix calculations, not only does the equation become much more simplified, but the calculations also become much easier. Here, the matrix is referred to as a 2D tensor, which is a very important concept in AI, especially in deep learning calculations. You can think of a tensor as a multidimensional array that includes scalars, vectors, matrices, etc. Here, dimension refers to the structure of the data. A scalar is the simplest form, which is just a single number like 1 or 0. A vector is an array of numbers lined up in a row. For example, you can think of it as a list of numbers in a single line, like 1, 1, 0, 1. A matrix, as shown in the diagram below, is a structure where numbers are arranged in rows and columns, which represents a 2D tensor. A 3D tensor can be imagined as a stack of multiple matrices, forming a cube-like structure. For example, it could be 3 4-4-4 matrices stacked on top of each other. A 4D tensor is a structure where multiple 3D tensors are stacked together. You could think of it as several cube-shaped 3D tensors grouped together. A 5D tensor follows the same concept, with even more dimensions stacked together. Now let's look at why tensors are important in deep learning. First, tensors allow for effective data representation. A tensor is a multi-dimensional array structure that can effectively represent and store large amounts of data, such as images, text, and audio. For example, a black and white image can be represented as a 2D tensor with only width and height information. Meanwhile, a color image, which has 3 RGB channels, can be represented as a 3D tensor with width, height, and color channel information. In addition, tensors enable efficient mathematical operations. Tensors allow for the application of powerful mathematical operations, such as matrix multiplication and convolution, which are essential for training and deploying AI models. Because tensors can handle complex multidimensional data like images, text, and audio, they serve as a powerful mathematical framework in deep learning.